Hello and welcome back to Engineering 11. We're in Lab 3 focusing on using a pendulum apparatus to collect displacement, velocity, and acceleration data and run some MATLAB experiments with this data. On screen here you see a video from the top angle of the single pendulum system. This was captured with just a regular digital camera. It's about 32 seconds worth of data. Here we have the mass moving back and forth. In the center we see the little black dot. Let's go ahead and take a look at how to convert this MP4 file. You see up here, short pendulum dynamics. I think I filmed the entire thing at like a minute and a half, but I focused on just a 32-second segment. Let's see how we can use an open source software called Tracker to convert this video of pendulum dynamics into a CSV file of measurements. Here we go. We begin this process on our favorite non-data collecting browser, DuckDuckGo, so much better than Google in this way. Let's go ahead and type in Tracker Physics Software. This was made by a community college teacher called Douglas Brown at Cabrillo College. He provides it for free because, you know, community college is the best place to get an education. Definitely sending my kids to community college. This software gives the ability to translate videos into displacement data. So what we would do is we would download it. Luckily, I'm already doing this. You don't have to worry about this. I just want to show you, if you were to actually run the whole lab by yourself without any support from a teacher, where you would get the software. In my case, since this is already downloaded, I go into the Finder, I go down to Tracker, I go ahead and open this. Here's the Tracker window. The next thing I'm going to do is to import a video. This particular video is in my Engineering 11 file. And I believe, to be honest with you, I put it in lesson 9 because that's the one I hadn't finished yet. Yeah, so it's pendulum dynamics short. Tracker's going to take some time to upload it. It's kind of a big file. Here it is. Next thing I'm going to do is to start imposing some frames of reference that I can use to measure. Here I have an axis. I put that axis through the center of mass, or at least the applied center of mass. Here we go. As the thing moves, I might actually want to capture this by moving it down this way, moving this one up this way. Let's try again. Not perfect, but not bad either, right? Looks like right about there. Yeah. The thing I can also do is I can move the origin closer, and then let's see what happens if that. So I would really like to have the 0 position of the y-axis right on the center of mass, and it's good enough for government work. Let's do it. Next, we're going to do what we call a calibration stick. Some of you might not be able to see this very well, but on the bottom of this video, I can actually zoom in there. These little tick marks are exactly 10 centimeters apart. That is a metric ruler that you see in that particular thing. This is a feature of the apparatus that Mike McCusker and I built together. Actually, he designed it, and I just built it at home to see if even an idiot mathematician could follow his directions, which I could, which was really awesome. So I just told Tracker, hey, listen, I want you to put the center, the 0, 0 of our frame of reference right here. I want the x-axis to be along the motion, the y-axis is this way, and then please, Tracker, recognize that the distance between these pixels, I want you to interpret as 10 centimeters, or in this case 0.1 meters. Use that distance to measure distances all over. So the moment that I tell Tracker that these two pixels are 10 centimeters apart, Tracker can now take any distances in pixels here and relate it back to this one. So I've just literally introduced an entire frame of reference from which I can collect data. Douglas Brown, the guy that wrote this software, makes it really easy for us to now track this data over the entire time frame. For the next thing we're going to do is we're going to track a point mass. So to track a point mass, I'm going to go ahead, let me zoom in here. I designed this so that there's really high contrast between the mass that I want to track. So in this case, I'm going to tell tracker, hey, that little black dot in the middle is the thing I want to track. And then I'm going to tell it a search region, because the claim of the matter is I don't want to search my entire picture. I just wanted to search right there. So that's now the thing that I wanted to search. Search region, there's some search features here. If you're really interested in this, you can get a sense by watching these videos. For now though, yeah, let's go ahead and just search this sucker. So now we're on the automatic feature. Check this out. Tracker is now converting, this is freaking amazing, right? Converting that image into displacement data. So here we've got a timestamp, here we've got an X and a Y. The X is the actual position in that frame of reference. It's creating a cosine curve, not because Tracker's doing that, but because that's the actual dynamics, which we're going to get to in this video. At the end of this process, I'm going to let it play out in front of your eyes. I'll fast forward it in the video editing software that I'm using so you don't have to sit through the 30-something seconds. At the end of this, we're going to have a .csv file that we're going to load into MATLAB, and then we're going to play. Here we are. I had to restart Tracker a few times. I broke my computer, which is always a fun thing to do. This is the same file that you just saw. I had to change the frame of reference because the computer didn't process it in the way that I was expecting. But what I want to show you is that over the 32 seconds of this video, I let Tracker run. It produced some data. Over in this table right here, I'm actually able to tell Tracker what I want. So in this case, I'm telling, hey Tracker, I want the frame, I want X data, I want Y data. I also want velocity in the X data, X component, horizontal motion in this case, velocity in the Y component, acceleration in the X component, and acceleration in the Y component. The next thing I can do is actually export this data. So if I go up here and I say export data file, in this case it's mass 2, and I can save this thing. The funny thing is I've already done this. In fact, here is the exact data file that I have. I'm going to be sharing this data file with you because you are going to use this data file to import position, velocity, and acceleration data into MATLAB, and then create visual graphics, solve a differential equation, and compare the solution with the actual collected data that we have in Tracker. That's basically how I got this data. In the next video, we'll talk more about the lab exercise that you'll do in this case. See you there.